Right, now read the question.
During a fermentation process,
The rate of decomposition of a substance
at any time t
at any time t
varies directly as the amount of substance.
Why?
And also as the amount of active.
Okay. Let's interpret the question. All right. Now, first thing first. Given a question, given a word problem question under differential equation, understand the concept, understand the word problem. Now, from that question, we are given a fermentation what? Process. Let's denote the fermentation process as Y, meaning that your fermentation process let's denote it as Y. Okay, now this fermentation process, okay, continue your reading.
Okay, the rate of decomposition of the substance at any time t.
Start again.
During a fermentation process.
Okay, which is why?
The rate of decomposition of the substance at any time t.
Okay.
Varies directly as the amount of substance Y.
Okay.
And also the amount of active ferment X.
Now, what this means is that this fermentation process that we denoted as Y, meaning the rate with respect to time. You know, the idea is when we say with respect to time, meaning the function divided by time. In this case, we are representing the function to be what? Y, meaning that dy over the t, right? Meaning that dy over what? dt. But in this case, we said decomposition. The idea of decomposition is what? Reducing. Meaning this rate of change, it is decomposing, right? By decomposing, meaning reducing. This implies that this fermentation process, we have it to be what? Negative dy over dx. Now, okay, dt. Negative dy over dt. Now, this rate of change of the fermentation process varies to what? The first one is what?
Directly as the amount of substance Y.
Okay, it varies directly
as the amount of substance.
Y. Now we are giving amount of substance. Amount of substance Y. Amount of substance Y. What else? Meaning this rate of this fermentation process is varies directly to the amount of substance Y. Okay.
And also the amount of active ferment X.
Also, this same rate of change of this fermentation process is still varies directly to what? Amount of substance X. Amount of active
ferment X.
Active ferment X, right? Now, applying the idea of variation from the first statement, we have that negative dy over dt is equals to what? Is directly proportional to what? Y. Call this one. The second one, negative dy over dt is directly proportional to what? X. Call this 2. Now, combining 1 and 2, meaning negative dy over dt is directly proportional to what? Xy. Call this equation 3. Then, of course, I will have a constant coming in. Now, let's say this constant is what? K. But before then, proceed.
If the constant
K,
proportionality is 0.5.
Okay, if the constant of proportionality is what? 0.5. Now, let's say the constant from here. Let's say we have negative dy over dt is equals to kxy. Call this equation 4. Meaning, in that case, the constant is k. Now, what's the value of k?
0.5.
The value of k is 0.5. All right. Moving on, what do we have?
Value of x at any time t.
The value of x, meaning the value of the active ferment x at any time t is what?
4/1.
X is given to be 4/1 plus t squared.
Okay.
1 plus
T bracket square.
All into bracket square.
You know, 1 plus 3 is in brackets.
okay 1 plus t all squared. All right, now from here continue.
Okay. And initially, y.
And initially, meaning we are giving initial condition for y. You are giving initial condition.
Y equals to 10.
Initial condition y is equals to 10.
So find y as a function of t.
Find y as a function of t, meaning the question now, question 1, y is a function of t.
And also the
Question 2, also deduce the amount
substance
of substance
remaining as t becomes very large.
as t becomes very large. Now, when we say very large, the idea, meaning, 1,000 is a large number, 2,000 is a large number, 3,000 is a large number, but you have to be specific of your very large number. So you can actually relate that to infinity. Infinity covers 1,000, covers 2,000, covers 3,000, meaning every larger number, depending on your own larger number. Now, let's say that you have to determine y when t becomes large, meaning when t becomes what? Infinity. When t becomes what? Infinity. Now, first thing first, having interpreted this question, we've interpreted this question. First thing first, find the function of y with respect to t. Meaning y is a function of t. By the time you know y being a function of t, you are going to substitute infinity anywhere you have t. Now, you get that from this equation 4. By equation 4, you can relate this to a differential equation. You can relate this to a differential equation. Now, when it comes to differential equation, expected, what type of differential equation is this? This is separable variable, right? This is separable variable. We said generally, when you have your differential equation of this form, let's say you have dy over dx is equals to function of y multiplied by function of x. Call this one. And 2, let's say you have dm over dp is equals to function of m multiplied by function of p. Call this 2. 1 and 2. Is this a differential equation? Are they a differential equation? Why is it a differential equation? Because it has a dependent function. For this first one now, it has a dependent function, which is what? Y, an independent function, which is x, and one or more derivative. The derivative in this case is what? dy over ds. Similarly, case 2, what's the dependent function? M. What's the independent function? P. What's the derivative? dm over dp. Now, what this means is that from here, you can deduce that whatever function, whatever you have as your function of your derivative becomes the function present in the differential equation. Observe, from here, you have dy over the x. The function becomes what? 1x. That's for case 1. For case 2, you have what? The m over the p. The function becomes what? M and p. So generally, meaning generally, to know the function in your differential equation, it depends on the derivative. It depends on what? The derivative. Now, let's apply the same idea to this equation 4. By equation 4, from what we've explained here, meaning the function, the expected function present in this, the expected function that will be present in this equation will be what?
Y and t.
Y and t. That's it. It is what? Y and t. From what we've explained here, we said, given this differential equation, of course, this is a differential equation, right? Yeah. How do I know the expected function that will be present in this differential equation? The idea is very simple. It depends on the derivative. Meaning, the expected function here is what? Y and t. But for this guy, this right hand side, I'm having what? K, I'm having what? X, and I'm having what? Y. Meaning this K and X, they has to be expressed either in terms of what? Either in terms of Y or T. You are not changing this guy because you already have it being a function of Y already. But you see this K and this X, they will change. Now, we don't know, is it changing as a function of T or a function of y. Now go back to that question. Given, you are given that k, which is the constant, to be what, 0.5. Are you with me? Meaning in place of k here, what do you have? 0.5. Now you are given that x is equals to what? 4 all into bracket 1 plus t all squared. In place of x, what do you have? This guy. Now let's substitute. Meaning we can write equation 4 as negative dy over dx is equals to what? 0.5. Substitute your x. That's what? 4 all over 1 plus t all square multiplied by what? Y. This is what? Equation 5. Now let's write equation 5 in a nicer way. Meaning negative dy over the t is equals to what? 0.5 times 4, that's what? 2. 2 divided by 1 plus t squared. Call this equation 5. That's true. 2y. Meaning we have what? Equation 5. And initially, we have equation 6. And initially, the question says that what? Find the function of y. Meaning y is a function of t. By the time you apply the idea of separable variable, you get y being a function of t. And earlier we said, given a differential equation, a function has been differentiated. The idea is that the function that has been differentiated, you have to find it. Now, check this guy. Check equation 6. What type of method of differential equation are you going to apply? Separable variable. Separable variable. Now, by separable variable, you know how it works. First thing first, cross multiply and do the needful. Now, let's solve. Let's see how it works. We want to solve equation 6. We want to solve equation 6, right? Now, let's do this together. That will be what?
Cross multiply.
Cross multiply. Better still, let's do it this way. Let's bring, this is the derivative of t. Let's take this derivative of t to this side. Meaning, I have negative dy is equals to what? 2y all into bracket 2y divided by 1 plus t square dt. And the idea when it comes to separable variable, we are isolating the function of y from x. But in this case, we are having y and t. Meaning you are isolating the function of y from t. Now, up to this level, how can you separate the function of y from t? This is the left hand side, and this is the right hand side. That will be what? You already know your task now. The task is either you make this left hand side to be the function of y or t, or you make this right hand side to be the function of y or t. Anyhow you do it. Just know that the left hand side we add one of the function, either y or t. Similarly, the right hand side, either y or t. Now, observe. It is easier if we make the left hand side. It is easier if we express the left hand side as the function of y. Why? Because by the time you multiply both sides by the reciprocal of the function of y, meaning from here, multiply both sides by 1 over 2y. Given this differential equation, what's the function of y? The function of y is what? 2y. The function of y is 2y. Then the reciprocal, meaning inverse, meaning that 1 over fy is equals to what? 1 over 2y. So what this means is that the reciprocal of the function of y multiplied by the left hand side and the right hand side. Multiplied by the what? Left hand side and the right hand side. Now let's do that. This becomes what? Let's do this together. That will be what? Negative dy multiplied by 1 over 2y, right? Equals to 2y divided by 1 plus t all square multiplied by 1 over 2y dt. Any question? For this left hand side, this is the left hand side. Let's do this together, please. This is the right hand side. From this left hand side, what do I have? Negative dy over 2y is equals to, this guy cancel out, right? I have dt over 1 plus t all square. Now integrate both sides. integrate both sides. Meaning introduce your integral sign. By integral, we mean integral negative the integral negative 1 over 2y dy is equals to integral 1 over 1 plus t all square dt. Now apply the idea of integration. Apply the idea of integration. You know, from here, let's integrate the left hand side. From this left hand side, factor out your constant. By now, you should be able to integrate. Given any integral for your level, you should know how it works. You should be able to integrate any integral function. Right? Now, from this place, factor out the constant. Meaning, negative 1 over 2 integral 1 over y dy 1 over y dy is equals to integral 1 over 1 plus t square dx. Now let's integrate it. Now this is what we'll be doing. We are going to integrate the left hand side and integrate the right hand side separately. Then we will create our answer. Solving for the left hand side. For the left hand side, meaning negative 1 over 2 integral 1 over y dy. This becomes what? Minus 1 over 2 ln y. This is your left hand side, right? Now let's integrate the right hand side. From the right hand side, I'm having integral 1 over 1 plus t all square dt. How do you integrate this? Using use substitution. How do you integrate? Let's do this together. Or we can't integrate this. What are these methods? By making what?
By making it 1 plus 10.
Okay. Will that work? I don't think so. It won't work.
I was thinking you
don't
use this formula.
What's the formula? No. This is different from integral 1 over 1 plus t square dt. It's different. Now from here, using use substitution, let's integrate, please. Using use substitution. Using use substitution, let u is equals to 1 plus t, meaning the u over the t is equals to 1, cross multiply. Therefore, the u is equals to what? The t. Now, let me say this. The idea of use substitution is that, now, check this question. The idea of this substitution. Check this question. This question, what is the function of this question? T. The initial question is in terms of what? T. But by use substitution, what you are doing is that you are replicating it, meaning you are changing it. Meaning the given function, which is t, you are changing it as what? U. You are changing it as what? U. What if you are saying using m substitution? Same idea. You are changing the old expression of t to what? M. Meaning, in place of this, the t, I have to express the t in terms of what? U. Since I'm using u substitution. Express the t in terms of what? U. Express open bracket 1 plus t close the bracket square in terms of what? U. By doing that, it becomes what? Integral 1 over u square du. Right? Why? Because this integral, this is it. This is it. Division, then 1 plus t. We've said let u to be 1 plus t, meaning u square. Then the t is already the u. That's what we did. Now let's integrate. By the time we integrate, meaning from indices, you can still write this as recall. When you have 1 over 2 cube, what that means is what? 2 raised to the power of what? Negative 3. Now when you have 1 over u square, meaning what? U raised to the power what? Minus 2. Now apply same idea here. It becomes what? Integral u raised to the power minus 2 du. Now let's integrate. What do we have? Add 1 to the power, then what you've added, repeat it. That becomes what? U raised to the power of minus 2 plus 1 over minus 2 plus 1, which is equals to u raised to the power of minus 1 divided by minus 1. Therefore, this integral is equals to what? Negative 1 over u. Negative 1 over u. What's u? 1 plus t. Substitute, meaning negative 1 over 1 plus t. Any question? Any question?
No.
Meaning that we've integrated the right hand side. Sorry, we've integrated the left hand side. When we integrate, what do we get? We got negative 1 over 2 ln y. For the left hand side, we got negative 1 over 2 ln y. For the right hand side, we got what? Negative 1 over 1 plus t. Meaning equate. Equate the left hand side and the right hand side. Negative 1 over 2 ln y. Let's do it together, please. Is equals to what? Minus 1 over 1 plus t. Right?
Are we not doing that?
Yeah, plus c. Plus c. Plus c. Then from here, negative cancel negative, right? Then you have ln y is equals to 2 all into bracket 1 over 1 plus t plus what? C. Hello? From here, what do you have? Up to this level, this is left hand side, this is the right hand side. What do? We cancel, observe, negative cancel negative. We are left with what? Ln y is equals to what? 2 all into bracket 1 over 1 plus t plus c, right? Now open up, meaning that ln y is equals to 2 divided by 1 plus t plus what? 2c. Plus what? 2c. Now, this 2c, okay, before then, from here, from the, was it equation 5 or equation 6 that we started integrating? 6. You know, from equation 6 that we started integrating, the idea is that we want to get the function of y itself with respect to t. But up to this level now, I'm having ln y. I'm having ln y. Meaning, how do I eliminate this ln? That was wrong. Take exponential to both sides. Take exponential to both sides. Meaning that exponential ln y is equals to what? Exponential 2 over 1 plus t dot exponential 2c. Now, exponential cancel ln. It becomes what? Y is equals to exponential 2 over 1 plus t dot exponential 2c. 2c, that's it. Can you see how logarithm entered calculus? It's actually interesting. Up to this level, we took logarithm, we took exponential to both sides, right? By exponential, meaning I want to eradicate this ln. I want to eliminate this ln. So from here, it becomes applying indices. From this left hand side, what it means is that when you have exponential all raised to the power of a plus b, it's still the same thing as writing what? Exponential a times exponential b. So that's what we applied here. Meaning, when we took exponential to both sides, we have exponential all into bracket 2 divided by what? 1 plus t plus what? 2c. So it becomes what? Exponential 2 divided by 1 plus t dot exponential 2c. And that's how we got this. Hope you are clear on that. That's how we got this. Now, question 1. Go back to question 1. Question 1 was what? Find the function of y.
Find y as a
Okay, find y as a function of t. Find y as a function of t. Now, check. We've done that. Y is a function of t, right? Meaning y is equals to what? Exponential 2 divided by 1 plus t dot exponential c. Exponential c. But in this case, you know, question 2 now says that determine the value of y when t becomes what? Larger. Now, the idea of larger is that we are substituting t to be what? Infinity. But, what's that? Oh, that's true. Now, from here, we said question 1 says that Find the, please let me read it.
Find
y as a function.
Find y as a function of t. This is it. We found it already. Y as a function of t. Question 2 now says that
Also,
deduce
the amount of substance
the amount of substance remaining
as
t becomes what? Very large. When we say very large, meaning infinity. But we are interested in getting this value when t is equals to infinity. Now, question 2. We said t is equals to what? Infinity. Meaning I'm substituting infinity into this equation. But you agree with me that by the time I substitute infinity into this equation, I'll still be having the expression here multiplied by exponential 2c. Yes. Let's say you want to move on with this question. So it becomes what? Y equals to exponential 2 divided by 1 plus infinity times exponential 2c. Let's say we've gotten this answer. This answer, let's say this is 5. I'm still having 5 exponential 2c. And from question, we want to know the value. We are not interested in the expression. We want to know the what? Value, the exact value. Hope you are getting my point.
Yes.
We want to know if this value is 0.5, if this value is 2, if this value is 3. Now, from here, what you are going to do is that you write exponential 2c as constant. All this guy is still a constant. Everything is still a constant. Meaning, let exponential 2c is equals to constant. The constant in this case, let's say a. Let's say a. Now, from here, meaning that this, let's call this one, meaning that 1 can be written as what? Y equals to exponential 2 divided by 1 plus t multiplied by a. Therefore, y is equals to a exponential 2 over 1 plus t. But we are giving initial condition.
Yes, of y.
We are giving initial condition of what? Y. And the initial condition is what? Y equals to 10. At initial condition, right?
Yes.
When y is equals to 10, c is equals to 0. Now, what this means is that we are going to substitute y and t into equation 2 so as to get a. Right? So as to get a. So from here, what do we have? We then have that 10 is equals to what? A exponential 2 divided by 1 plus 0. Meaning 10 is equals to a exponential 2. Right? Now from here, make a the surrogate of the formula. Meaning divide both sides by exponential 2. This cancel out. Therefore, a is equals to 10 multiplied by 1 over exponential 2. Which implies that a is equals to 10 exponential minus 2. Now we found a. Substitute this a into equation 2. From equation 2, we have that y is equals to a exponential 2 divided by what? 1 plus t. And we already know that a is equals to what? 10. A is what? 10 exponential minus 2. Therefore, y is equals to what? 10 exponential minus 2 multiplied by exponential 2 over 1 plus t. Right?
yes.
Any question? What we have is that, up to this level, we're actually done. But we want to finalize our answer, meaning we want to get y in terms of t. If you go with this, you're actually correct. But we can still simplify further. Then for me, I apply the idea of indices. Meaning, or it's logarithm, meaning that y is equals to 10 exponential, all into brackets, negative 2 plus 2 over 1 plus t. Multiplication will change to plus. Now, let's solve this guy. Negative 2 plus 2 over 1 plus t over 1. Let's take the LCM. That's what? 1 plus t. 1 plus t divided by this, that's what? Negative 2, all into bracket, 1 plus t plus 2. Now, let's distribute the numerator, meaning negative 2t plus 2 all over 1 plus t. This cancel out. I have what? Negative 2t over what? 1 plus t. Hello. We have negative 2t over 1 plus t. Now, meaning that from here, we can write y y equals to 10 exponential. In place of all this, we solve it to be this, meaning raised to the power of negative 2t over 1 plus t. And this is question 1. This is question 1. Question 1 says that express y in terms of t. We found out already. All our answer here, everything is with respect to t. So you are done. Now, question 2. Let's answer question 2. Question 2 says what?
Is when deduce the amount of substance remaining as t becomes very large.
Deduce the amount of substance as t becomes very large. Deduce the amount of substance as t becomes very large. Now, when we say very large, the very large is not specific. Let's say, for instance, let's say t is equals to 1000. Let's say t is equals to 1000. Let's call this case 1. Let's say t is equals to 2000. Let's call this case 2. Let's say t is equals to 10,000. Call this case 3. 1, 2, 3, they are larger numbers. They are larger number. Now, how do you know the actual larger number that they are referring to? We can just generalize this as saying infinity by larger number. Let's say infinity, meaning that in this case t is equals to infinity. Now, what this means is that given this function, anywhere I see t, what will I substitute? Infinity. Now, meaning I have y equals to 10 exponential negative 2 infinity divided by what? 1 plus what? Infinity. Now, the idea behind infinity is that whenever you add a number plus infinity, you still have infinity. Meaning the infinity does not change. It doesn't change the value. Now, to actually know that that's correct, when we say, let's say the larger number is 1000. Case 1, the larger number is 2000. Case 2, the larger number is 10,000. Case 3, we now categorize everything as infinity. Meaning you are saying that 1000 is equals to 2000 is equals to what? 10,000. Now let's say you are going with 1000. Meaning 1000 plus 1. That's what? That's 1001. Which is still infinity. Now what this means is that you have 10 exponential negative infinity over what? Infinity. Observe, infinity cancel infinity. That becomes what? Yes. To get y. I said earlier that you want to get y. What was y? The amount of substance. You want to estimate the value. Abi, up to this level, observe, infinity can cancel infinity. It is fraction now. It is fraction. When you have negative 2 infinity over infinity, infinity cancel infinity. Therefore, y is equals to what? 10 exponential negative 2. Negative 2. Now, input this in your calculator. 10 exponential negative 2. What's the answer? 10 exponential negative 2. What's the answer?
1.3.
What did the man get?
1.3.
Can you see? So from here, let's finalize our answer. By the time you put this in your calculator, what's y? Y is equals to what? 1.335. And this is question 2.
No. Thank you.
Thank you.
This is question 2. Deduce the amount of substance when t becomes very large. Meaning that when t becomes very large, this is the amount of substance. So you can write, therefore, the amount of substance when t becomes very large is equals to what? Becomes very large is equals to 1.35. And t becomes very large when t is equals to what? Infinity. When t is equals to what? Infinity. So these are the solved word problem relating to differential equation.